Please give a second warm welcome to Falcon.
Hello, good afternoon. Okay, I'm going to steal this one then. Let's just do this. This is easier. Yeah, thanks again for the warm welcome. This is my, I think, 5th confession at this point. Developer-friendly threat modeling. So yeah, probably since the last time that you saw me, I went and got a business degree and kind of spent a lot of time trying to figure out how to manage product security at this cool Finnish cloud company. Open source, multi-cloud, trusted data platform for everyone. And what I learned while doing it is kind of just how important it is to focus our threat modeling efforts in a way that is sort of sustainable, comprehensible to developers, and maybe a little bit less by the book and a little bit more focused on our ultimate goal. So that's kind of what I'll be going through today. Start with the definition. What's threat modeling? Why do we do it? We don't do it for any reason other than to figure out what your threats are. So we go through this cycle, and because I'm here in DC, I'm going to imitate the federal government presentation style and make these arrow diagrams. We move through 3 phases when we're doing threat modeling. Very simply, the point of it is, what are our assets? What are threats? What controls do we need to protect those assets against those threats? That's the 3 things that we do. So you can already discard the majority of what you have been taught about threat modeling. We don't necessarily need a lengthy checklist. We don't necessarily need a framework other than this process. What do we need to do to identify our assets, identify what threats might impact on those assets, and, and what controls we're going to need to do them. So what's threat modeling? We do threat modeling to identify necessary controls. We map them from assets to threats to controls. Very easy. I don't know how we ever got into the situation that we are with threat modeling. So what came before? Well, broadly, this process is the same type of thing as the OWASP threat modeling process that is continuing to be published as of this year. Citation to it. My steps are basically the same as these steps. Decompose the application, determine and rank threats, and determine countermeasures and mitigations. Well, that's the same thing as, really almost the same thing as asset identification, threat identification, and control identification. So, I don't know, why don't we get started and try on the OWASP process for size and just see how it's gonna work. The OWASP process here starts with these entry points and coming up with the DFDs. And if you go to the OWASP page that describes this, you will see them begin by talking about basically making a data flow diagram of all of the parts of your microservices, every component of your application, and figure out what the entry points are for the data, how it flows through the system, how each of those flows might be impacted by an attacker, and what the ultimate outputs of the system are kind of tacked onto the end there. The part of this that gives me pain is that not everyone has privilege boundaries that are quite exactly representable on a data flow diagram. In fact, very few assets are even representable on a data flow diagram. More to follow on that later, but let's look at one of these. You've seen one of these before. Microsoft released this great pile of 8.5 megabytes of Visio and shame to the world many years ago, Threat Modeling Tool 7. And what Threat Modeling Tool 7 gives you is it gives you a diagramming tool whereby you can depict trust boundaries. You can see them in the red outline around these if it's big enough. And within those trust boundaries, you put each of your assets, more to follow on that for a reason, and then you draw the data flows between each of those assets. So I've depicted a little toy diagram here where we have a web server that has one dependency on an OS process in CorpNet, because it's the Microsoft threat modeling tool after all. And it communicates over HTTPS with a process on the host operating system that may or may not be Internet Explorer, because again, it's the Microsoft threat modeling tool, right? And it has a communication with the file system, because the point of this is it downloads a file, so it has to save it to the file system. And it controls a device, so it has an ioctl interface to the device that's outside the browser threat boundary. Now, the thing I want to ask you, though, is this a threat model? I mean, we're here, so I think the answer is more or less a foregone conclusion. This is a data flow diagram, sort of. It sort of tells us how data comes in and out of our system and which components touch that data in which ways. And if we marked up everything appropriately, it would tell us things like, oh, here's an HTTPS flow across a network boundary. So obviously you have threats related to certificate interception certificate forgery, TLS interception attacks, TLS stripping attacks. All of these things impact on you, right? clearly. And you have a binary flow from the OS process into the file system. Well, maybe that binary flow is spoofable in some way. Maybe the binary stuff is not the stuff that you thought it was. Maybe there's just too much of it and it fills up your disk. And a person is to believe that these constitute threats. All right, here's our threats broken down in the output of this tool that has been the industry standard for many years. Potential excessive resource consumption for OS process and file system. Denial of service. Does the OS process or the file system take explicit steps to control resource consumption? It's going to be hard to deal with. Maybe it makes sense to let the OS do the job. Be careful that your resource requests don't deadlock and that they do timeout. Well, that's a lot for saving a file to disk from my web browser. Is that really where I want to be concentrating my resources in my web-based application? Is this really going to be threat number one, and is threat number two going to be spoofing of the destination data store file system? You mean you're going to impersonate the disk running on the client's workstation somehow? And okay, so the point I'm trying to make here is that this DFD-based threat modeling process, while it certainly has its place, and if you are running a large communication system with many untrusted data flows, maybe this is the thing for you. If you're not, it might not be the thing for you. And really, the root of this is what we're doing is we're inventorying the parts of our system that are actually meaningfully subject to attack. Oh boy, this is exciting. We'll just give that a moment to recalibrate. So we're going to enumerate the parts of the system that are meaningfully subject to attack. And if we're running a communication system, it might actually be these things that are meaningfully subject to attack. If we're not, it's not likely to be. So, stride. That's what that tool is based off of. It enumerates the components of the stride model, which are up there for you to read. You've read them before. Well, do these things encompass all possible threats? Because the great promise of this DFD-based approach was to say, if we only enumerate all of our assets and all of our data flows, more to follow about that word assets, then apply this framework to them. Well, okay, here's our HTTPS flow between our web server and our browser. What can be spoofed, what can be tampered with, what can be repudiated, what information leaks out, how can someone DOS it, is there an avenue for EOP? Clearly, that enumerates all possible threats, right? Well, it also turns out that all computers are DFAs and the set of natural numbers is countable. Good job. I mean, technically, you're kind of right, but you'll never get there. So, why don't we reframe the question a little bit? If our favorite named APT exhausts the resources of the pipe between the OS process and the file system, what is the probable consequence to my business? And the answer here is likely nothing. The client's gonna have to get a bigger or faster disk, change how they use the application, spread the load out a little bit, maybe make better assumptions about how the application might use the disk. Hey, how big are those files that we download? Is our disk half the size of that? At the boundary of the probability, they might ask us to increase the application performance, compress something, or prune our logs a little bit more frequently. And we ask again, is that eventuality what I actually want to be devoting my scarce security resources to? So what is the probable consequence to my business? My customers will have to actually use my application in the way that it's intended. Big whoop. I don't have an example of a good threat from this threat model because I didn't find a good threat in this threat model, and that should maybe tell us something. So as I rip off IBM here, computer services are the things that we use to make money or enact our other objectives. We might have other objectives than making money. So therefore, our computer services are merely a means to implement a business process. So we have to stop missing the forest for the trees, which is what we do when we imagine that our data flows between each of our microservices and system components are applications to defend, assets to defend. The assets to defend are actually our business processes. So let's go back here. Which of these things is a business process? Again, point made. So that's what we want to do. And I'm flipping the definition of assets on its head here. An asset is something that we use to enact our objectives. So one of the most important assets of many of the businesses that we operate when we come to ShmooCon, people say nice things about us, like FedRAMP compliant and issued ATO or ATO ready, so that other people give us money. That's an important asset. If something impugns my compliance with a standard that causes me to give people money, that thing is a threat. Yeah. Yeah, I'll repeat that one more. So, sure. So, the fact that people hold us in compliance to our standard, and that is the reason that they're using our software, that's kind of the fact that I can say, yes, I do comply with that. That's an asset for my business. It's actually one of the most important, expensive assets that I have, the asset on which I spent the vast majority of my compliance and security development resources. Other ones that apply to basically any business. It is broadly known among our users that our service is reliable. Well, that's also an asset. It has threats, such as somebody DOSes me, it's no longer reliable, people stop believing that it's reliable, and then they stop giving me money and I go out of business. Okay, another asset. We charge our users a monthly subscription fee and they do not charge it back. Well, okay. There's some threats to that, such as what if my payment processing is destroyed because somebody replaces my Stripe API key with their Stripe API key. Now we no longer charge our users a monthly subscription fee and we're sunk. Each day we live our corporate values. Well, what if my value, my goal of being the secure and trusted open source data platform for everyone, if it's no longer secure because all of the customer data leaks out, then I'm not really living the corporate values and somebody might have something to say about that. So my ability to continue to do this is the asset to defend, not the server on which that data is stored. And if we start our threat modeling there, we no longer really need a DFD to figure out the quality of our computer system that affects the property that it is broadly known among our users that our service is reliable. It's just a different layer of abstraction. And where do I get this? It's not just something that I made up. It's actually the accounting definition of an asset, which is something we control that we expect to provide a future benefit, in less words. There's more words in GAAP. You don't need them for this. The threat, it follows from that, is anything which reduces that future benefit in any way. At all. It's literally anything that says, hey, my asset no longer provides me a future benefit. And then control is the means that we do to put a stop to that. It's very, very simple language. Control also has many other definitions, but this is the one that we're going to use because it's easy. So now that we all speak the same language, we can elaborate a little bit. Don't forget how nuanced controls really can be. It can be anything from a security system to your logs to your incident response. A control can even be your shared responsibility model or an insurance policy that you have. It's anything that lessens the realizable annual loss expectancy from your threat. And that's kind of the things that we want to put in our threat model. We don't necessarily need our threat model to have mitigations like, well, yeah, it's going over the internet, but it uses triple DES, and triple DES is in FIPS 140-2, so it must be that our communication channel is secure and we're fine, right? Yeah, a little more creative than that, but your control is something of the form, I know that this communication channel is secure because I have taken certain steps and those steps are backed up by these citations is a little bit better. Also controls like, well, I offer the most secure cypherspec, and if my customers actually care about this, they negotiate the most secure cypherspec, can also be a pretty solid control as long as you make that argument explicitly. But just don't forget how nuanced control is. It's really just any words that are responsive to the threat at all, which is anything that has an articulable way to impugn the benefit that we get from our asset. So be careful of the completeness trap. Don't fall into the completeness trap because the rumors are true. All computers are in fact deterministic finite automata. And you can in fact enumerate every possible state of those computers if you have another computer of exactly that size or greater. And it's just not helpful because compositionally you know that your system running on the abstract platform for which you wrote it is likely to be Turing complete or near there too. And so language theoretic security, which I must of course tie into all of my talks, it gives us that we have to do more. Stride is a really reductive framework. It's sometimes really nice brainstorming food, but don't think that by going through each category you will have demonstrated this completeness MacGuffin, because you don't actually get completeness no matter what you do. You cannot enumerate all threats, and you cannot enumerate all possible controls. You might find that by repeating the process, that's that other MacGuffin, repeatability. Everyone likes to say that in security. I want the same result. I do the same thing twice. I want the same result. I want it to be comparable between date A and date B. You just don't get that. Because if you repeat that process with different stakeholders in a different room on the same day, you're going to get a different set of threats and a different set of controls that are responsive to them, and that's okay. especially if they're not all indoctrinated in your rigid corporate threat modeling process and they all just went through Stride. Then it will be comparable, but it will be wrong. Why? Hi, Geidel. This dude told us that we cannot reason about non-trivial properties of Turing-complete systems. It passed through a few other people when we got to that point, but if we can't solve the halting problem as general case, it follows that we can't come up with a process for enumerating all possible threats. Especially on an even larger system than the one that we already can't reason about, such as the toy Turing machine. So how about we just each do our best? Everyone has a role to play in this process, and it's basically just a big brainstorming exercise. If you are having trouble, you can use Delphi. If you have people who are reluctant to criticize others in certain ways and pass it through the Oracle, but you don't even have to do that. What you have to do is recognize that the developers and their managers are the ones that know how the business assets that they made generate value and what systems we use and how, and those are what our assets are. So developer-driven threat modeling means that the developers are the ones who identify the assets. And then they tell you all the nightmare scenarios that they think, oh, well, I had doubts when I wrote this might have happened. And they tell you what they've been doing to prevent that. So therefore, I did this. And you as the security professional have just 4 jobs. What are some other controls that I know about that are available? Are those controls feasible? Do we have control requirements to which we're subject that you need to have something in there that you don't? And what are the nightmares that are lived by others? Those are some other threats. But your job as a security professional is just to evaluate. Are those really the assets? Are your threats to those assets complete? And is what you're doing about that, does it make sense? Is it fully responsive, or is there something else that we need to do beyond that, or is there something we're doing you don't need to do? So here's an example. Asset A1, user data remains confidential. Notice that that's not the server and it's not the key. Threat 1, I enumerate them because I like to refer to them by number later. Asset 1 is compromised by credential leakage by a customer. The customer gave up their access key and now all their data is out there on the internet. What are we going to do about that? Well, you might think shared responsibility model. You would not be wrong. But we can do 3 other things besides that. I'm going to make sure that credentials are prefixed. So they start with some magic string and it requires that to be in there so you know, hey, if I see this, GitHub can maybe figure out with its secret scanning tool that that's the kind of thing that it is. Credentials used to access the data are randomly generated, so you can't just guess them. It's not password 123 with the magic prefix. And just by doing these 3 things, I can actually go beyond just, hey, it's a shared responsibility model, bro. I don't know what to tell you, to actually helping our customers ensure that the user data remains confidential, which protects customer trust, which was in our values, and that's how user data remains confidential becomes an asset. So we say, okay, well, we did randomly generate them, but Control C1 and Control C3 yet to be done. Hey, wait, I actually just made a Jira epic, and I just made 2 story tickets. And I made a threat model. So I hope that'll make sense. I think I'm just about out of time, 12:49, so I guess the point I want to drive home here is pare back the security team's role in threat modeling. Explain how to do these things, these story tickets when called upon by the developers and asked, and validate on an ongoing basis that these things remain done, which is a process that we might otherwise know as control evaluation or pen testing, depending on which school of thought you follow. But your goal is to facilitate a conversation when you're threat modeling. Your goal isn't to go through a checklist and say, hey, these 13 items must be addressed for every service in my major cloud platform. It is literally just to say, have you identified all of your assets, really all of them? Have you told me everything that you could conceivably do to prevent the threats to those assets from actually occurring? And you can use a framework like Stride, go through it point by point by point, as brainstorming food, but it does not get you from start to finish, ever. So I think I have about maybe 5 minutes for questions, and then we're moving on. What? No? No one? Harsh. Hey!
How do blue teamers who do the threat modeling and red teamers kind of collaborate and hand out more efficient pen testing, better pen testing results?
How do red teamers and blue teamers who are doing the pen testing and control development collaborate and come together to deliver more efficient pen testing results? Well, every time that you come up with these controls, you keep an inventory of these controls and you call that thing a baseline. And when we're pen testing, we pen test to the baseline, among other things. So as a red teamer, you have that unique ability to be creative and come up with fresh new threats that no one has thought of before, and you actually just add them to this. And then when you have a result, you can come back, circle back to the blue team and say, hey, did you think of this threat? What are your controls against it? I tested them and I found that they didn't work. Here's some other things, and that's my recommendation section. Here's the other things that you can do. We add them to the control framework, we add them to the baseline, and we keep the cycle going. That answer? All right. Okay, I think one more question, yes? All right, I'll take one more, go ahead.
So it seems like you're saying to go back to more subjective views or qualitative ones rather than quantification, qualitative.
The question was, it seems like I'm telling you to stop being quantitative and be more qualitative. The answer is nuanced. For so long as we keep building systems for which we cannot abstractly reason because they are so complex, i.e. Turing completes, yes, you have to be subjective because objectivity is unavailable. If you choose to build systems that are less complex than this, that you can actually fully enumerate all of the threats, everything I said, just throw it right out the window and do formal verification because that's what you bought yourself. And you'll be much happier. So he's not wrong. All right, anyway, I'm going to stop talking and let them introduce the next speaker. Thank you.